Hello everyone. In today's video, we will be learning about Border Gateway Protocol simulation, and we will also perform Cisco Packet Tracer simulation to understand how it works in real life. Let's begin with a short introduction of Border Gateway Protocol. Introduction to Border Gateway Protocol. It is used to connect different networks or autonomous systems. BGP helps routers share routes across the internet. It chooses the best path for sending data between large networks. BGP is the main routing protocol of the internet.
Now let's move on to the Cisco Packet Tracer simulation. On the left side of the Cisco Packet Tracer, we have the device categories panel. This section contains all the network devices we use to build our topology. The main categories include end devices such as PCs, laptops, servers, etc. Switches used to connect the devices within the same LAN, and the routers used to connect the different networks. Here we have different wires which can be used for the connection. For this project, I mainly use devices from two categories, that is routers, switches, and devices, that is PCs, and I used straight through copper cables for all the LAN and WAN connections. Now let me explain the devices I used in my topology. I have used 3 routers, 3 Cisco 2811 routers. They represent 3 different autonomous systems in this project. Each router is connected to a LAN through a Cisco 2960 switch, and each switch is connected to a PC which acts as an end device for that LAN. Here you can see the complete layout. PC1 is connected to switch 1 and switch 1 is connected to router 1. This forms the LAN for autonomous system 1. Similarly, PC2 is connected to switch 2 and switch 2 is connected to router 2, which forms the LAN for autonomous system 2. In the same way, PC3 is connected to switch 3 and switch 3 is connected to router 3, which is the LAN for autonomous system 3. Now these routers are connected to each other in a straight line. Router 1 is connected to router 2 and router 2 is connected to router 3. These connections represent the inter-AS links where the BGP will run. All the connections are made using the copper straight through cables because the devices are different types: PC switch, switch switch. All the connections are made using the copper straight through cables because the devices are different types: PC switch, switch router, router. I used 3 routers, 3 switches and 3 PCs. Each PC switch router group forms one LAN. The routers are connected to each other to form the backbone network. This entire setup is used to demonstrate BGP inter-domain routing between the autonomous systems. Next, I will show you the packet traveling from PC1 to PC3. Here the request packet goes from PC1 to switch 1 and then from switch 1 to R1. The R1 forwards the packet to R2 because R2 is its BGP next hop for that network. Then R2 sends the packet to R3. R3 forwards it to switch 3. And finally the packet reaches the PC3. Now you can see the blue reply packet returning back from PC3 to PC1. This confirms that end-to-end connectivity across all the 3 autonomous systems is working perfectly. I will demonstrate how the packet travels from PC1 to PC2 using the simulation mode. Switch to simulation mode. Filter for ICMP only. Later, in the PC1, just go to the command prompt and type ping 10.2.2.10. So the packet just travels from PC1 to PC2. So you can see the ICMP request packet leaving PC1 going to switch 1 and then to router R1. From router R1, the packet is forwarded to router 2 through the network. Once the packet reaches the router 2, it is sent to switch 2 and then finally reaches to PC2. Now the packet is traveling back to switch 2. Later, it is traveling back to router 2 and then it is moving to router 1. Again back to switch 1. And reach the PC1. This confirms that the communication between the PC1 and PC2 is working correctly through the BGP. In conclusion, this project successfully demonstrates how BGP enables communication between different autonomous systems. All routers exchange routes correctly and the simulation confirms smooth packet flow across the entire network. This project clearly shows how interdomain routing works in real-world networks. Thank you.